Hello and welcome back to Jacubication. This is the next video of Chapter 0, entitled Conditionals. Some background definitions. A statement is a unit that expresses some action to be carried out. A unit, because it can be a simple single-line statement or be composed of many single-line statements that join together to form a single unit. An example, a simple statement is just x plus 3, an assignment statement. A compound statement, you don't know any useful ones of these yet. An expression is a unit that can be evaluated to determine its value. A unit, because it can be a simple single value or be as many values as you want, joined together with operators. A simple expression, just the number 3. A compound expression, hello plus space plus world. Scope is where variables can be seen in a program. In some languages, if you declare a variable in an if statement, that variable can't be seen outside of the if statement. If statement. The overarching concept is, do some statement or statements if some condition is true. The anatomy of an if statement. The if, the word itself, it's always there. Boolean value, the condition you're checking. And actions, the statements to perform if the Boolean value is true. An if statement is a statement because it joins together the simple statements of the Boolean value and the actions into one larger compound statement. Real life example. Telling this to someone going to a store, get ketchup if they have it. The condition is whether or not the store has ketchup. The action is getting the ketchup. Flip a coin. This is a program that tells the user the result of a coin flip. The result is H. If the result is H, the answer is head. If the result is T, the answer is tails. This is arguably poorly designed. You either flip a head or tails. This code asks if you flip to tails, regardless of you already flipping a head being true. This will never be the case, so there has got to be a better way to express this idea. And, side note, the previous video's title was Straight Lines because of indentation of conditionals and other similar statements. If you look at the example, there's indentation. Else statement. This is a program that's a flip of the last one, where instead of if result equals H, if result equals T, it says if result equals H, else. An else statement must be paired with an if or else if statement above it. Expresses that if the conditional above it has evaluated to false, then do the actions that are associated with the else statement. This is better designed. If you haven't flipped to heads, you've obviously flipped to tails, so you don't have to ask again. The else statement accomplishes this. Extending the ketchup example. Get ketchup if they have it, otherwise do this. The otherwise is the else. Stacking ifs. These are two programs that say if the number equals the numeric value, the answer equals the string version of that number. Basically, only ever do this if you're asking questions whose answers will never have any overlap, like flipping a coin, rolling a die, etc. In the ketchup example, you're making many different food requests. If the store has ketchup, if the store has mustard, if the store has relish, if the store has hot dogs, if the store has barbecue chips. The else in this program on the right here gives you unexpected results, as in this case, it will always fire if the statement evaluates to false, meaning, on the right example, if the number isn't 5, the answer will always be string 6. So code the way on the left. Else if statement. In Python, it's abbreviated to elif. If the above if or else if statement evaluated to false, evaluate this statement. Comes with a bonus. Once one condition evaluates to true and its corresponding statements are ran, execution continues past the if, else ladder. Call it a ladder because it's one solid thing and you move down the rungs as the conditions evaluate to false. Ketchup example. It's a contingency for the absence of ketchup. This program on the bottom right here is a grade scale that I had in high school. If your grade's greater than a 92, it's an A. Else if it's not greater than a 92, if it's greater than an 84, it's a B. If it's greater than a 76, it's a C. If it's greater than a 69, it's a D. Else, it's an F. If you didn't have the elifs there, if you got an A, you would also get a B, C, D, and F because there's no signal to stop early. And in this case, with the ketchup example, it's similar. You don't have to keep going to the store and going down your list of contingencies if they already have the ketchup. Ladder. An if, else ladder should be understood as one solid thing because you can't write any non-conditional statements between the else if statements. As you're going through catch-up contingencies, putting statements between these contingencies will be breaking up a complete thought. Similarly, an if statement not connected to else if or else statement is one solid thing. Therefore, you can put any number of statements between stacked if statements. The latter can also be made of as many else if statements as you want, as long as the latter starts with an if. Ending the latter with an else is entirely optional. Many times, ending the latter with an else can be bad design because you're willfully ignoring an error case that couldn't possibly happen. Fizzbuzz Modified, a popular children's game where, in my version, if the number is a multiple of 3, the answer is Fizz. If the number is a multiple of 5, the answer is Buzz. And if the number is a multiple of 3 and 5, the answer is Fizzbuzz. Setting the answer to Fizzbuzz multiple times will be the first time you've seen the popular theme in coding. If you're copying code, you're probably designing your code poorly. In this example on the bottom, you're setting the answer to Fizzbuzz multiple times. Nesting ifs versus ands, or the double ampersand. Nesting ifs can be trivially replaced by just joining the two separate conditions with an and, like so. In this example, if the number is multiple of 3 and it's multiple of 5, the answer is Fizzbuzz. Else, if the number is multiple of 3, the answer is Fizz. Else, if the number is multiple of 5, the answer is Buzz. Not to say avoid all nesting at all costs, though. Like many things in life, it's a balance, and nesting has a time and place. The balance. This checks eligibility for U.S. federal offices, and it greatly simplifies the Constitution, as it just says, are you a citizen, what's your age? On the left example, if you are a citizen, it nests and then asks you the age question for the various things. And on the right example, it asks every time, are you a citizen and what's your age? Are you a citizen and what's your age? I would say the nesting looks cleaner here, as you're not asking, are you a citizen 4 times. The balance is, try not to ask the same question over and over again, and nesting deeper than 3 levels gets stupid to handle and think about. Use of the or double bar. This finds if a letter is a vowel or consonant. If it's an A or an E or an I or an O or a U or a Y, it's a vowel, else it's a consonant. This brings up another theme in coding. If you go much past column 80 on a single line, you should write the line differently. Yes, there is a way to make this code shorter. No, you don't know the best way to do this yet. Switch statement. This is a JavaScript example. The expression between the parentheses and the case work together. So in this case, the OP, the operation variable, and what's in the case variables are compared. So if the plus sign equals the plus sign, add the 2 numbers. If the minus sign equals the minus, if operation equals the minus sign, subtract the numbers. If operation equals the multiplication sign, multiply the numbers, and so on. The break ensures that one true exits the entire switch statement. The default happens when all other cases are false, or happens last if no breaks are used, because if no breaks are used, it goes through every single statement like you're stacking ifs. Use of not, or the bang operator, can be used to factor out nesting, but generally it's better to use different operators or refactor logic. This is the eligibility example again. If you're not a citizen, you're not a citizen. Otherwise, you are a citizen, so we can ask you the age questions. Short-circuiting has to do with and or. In an if statement, if the first Boolean value in an and is false, the second is not evaluated. In that bottom example, if you don't have the money, thirsty is never checked. If the first Boolean value in an or is true, the second is not evaluated. If the letter is an A in that top example, none of the other Boolean conditions are checked. De Morgan's laws. Named after British mathematician Augustus De Morgan. These 2 laws prescribe how a not distributes across an or an and. Not A and B becomes not A or not B. Not A or B becomes not A and not B. Basically, a distribution of a not flips the logical operator to the other one. The issue number 1 that comes up with ifs is optionally omitting curly braces. This doesn't come up in Python. In languages like C, C++, C#, Java, JavaScript, PHP, etc., where if statements are surrounded by curly braces, you can optionally omit the curly braces if your if, else statement is less than a single line. This doesn't come up in Python because by it trading forcing indentation for curly braces, there's not an option to omit anything. There's hardly ever any upside to this, and more often than not, It's bad because if you later go back and add code, then your if statement won't function like it's supposed to. An example. On the left, it's your coin flipping example again, and on the right, you add a tally that if you flip to heads, you increment the heads value, and if you flip to tails, you increment the tails value. This code on the right functions like the tallies were written at the end of the ladder, as regardless of what you flip, both values get incremented. Issue number 2 is the dangling else. Then this follows from optionally omitting curly braces. The else will match the nearest if, regardless of the indentation. Like the left and right examples, they're the same code, but regardless of the indentation, that else always matches with the if the age is greater than or equal to 35. Seriously, just use the dang curly brace. In the next video, we'll cover loops. Ciao.